to the right of where I drew it. So I asked you a question so that we could figure out and trace that more precisely. What was the next question?
Compute the weight of E that generates the
Minimum variance portfolio.
Yeah.
So find weight of E such that sigma P is min. And so we calculated that there was that formula that we applied. We found a weight, and then what do we do with that weight? WE sigma min. We use that to find what? To find the expected return of the MVP. That's how we called it. And the risk of the MVP. Is that right? So once we found his weight, let's suppose this was it. WE that produces the MVP. We were able to quantify the risk of the MVP and able to quantify the expected return of the MVP. Yeah. What was the next question?
compute the weight of E for the optimal portfolio for an investor with A equals 10.
Okay, so do we answer that question?
Yes.
Yes.
No, we are.
So
Did we?
Yeah, we answered that. We
Yeah.
answered
Point
that.
three?
That's where we left off.
Point
That's,
3?
Point
Yeah.
3.
find a weight of equity such that U is maximized for the investor with A equals 10, right?
Yes.
So we use this thing right here. I forgot. The weight of equity that maximizes the utility. What was the formula for it? That was that very long thing.
Yeah.
That contains A's, right? So the one you need to remember is, well, if you're doing something for the investor, you need to know the investor's characteristics. So the formula must contain the coefficient of risk aversion. So we use that long thing, and what do we find?
0.302,
So what does it mean?
30%.
This guy has to invest 30% in equity and roughly 70% in debt. So once we found those two numbers, once we found this number, and implicitly we found the weight of that, yep, we calculated the expected return and risk for the optimal portfolio for the investor. Did we do that?
No.
Or we stopped at this point?
Yeah.
I think that was the last, yeah.
This is the last thing. So how do we calculate the expected return and risk of this portfolio? Well, the expected return is just a weighted average. So this is the optimal portfolio for the investor. We call it ORP. And it's the weighted average of the return, so it's the weight of equity of the ORP, which is this thing right here, times ERE plus 1 minus the weight of equity that generates the ORP times ERD. Yep. So use those characteristics of the portfolio, of the two assets, put them in here with the weights that you just found. This tells you what is the expected return on that ideal portfolio. So what do you expect it to be? So I don't remember what was the value for the minimum variance portfolio. What did we calculate it to be?
It was 0.23.
0.23. So the ideal portfolio for this guy has a weight of 0.3. The weight of equity that generates the ORP. So it will have this much risk and then much return. So with these, we're calculating this value right here. And then we can use the formula for risk. Which is the weight of equity or P times sigma E plus weight of debt or P sigma D squared twice the weight of equity or P 1 minus the weight of equity or P covariance. So plug all the stuff in there and it will tell you exactly the location of this point. Yeah? Questions? So we're doing the same thing over and over again, right? I mean, it's getting pretty old here. So on D12, practice those quizzes. Make sure you can replicate those graphs and you look at the question. The question will tell you what I want on the x-axis, what I want on the y-axis. So the question will kind of give it away. Got it? All right, so let's extend these a little bit. And what happens when shorting is allowed? And you're still dealing with two risky assets. So what do we know about weights when you're shorting something? The weight of the asset you short is the weight of the asset you short is negative. So the fact that you're shorting means that either WE can be less than 0 or WD is allowed to be less than 0. But remember the constraint is that the two weights are always equal to 1. So if one asset has a negative weight, and you're shorting it, that means that you're going extra long on the other asset. Yeah? So, what happens to the graphs? Well, let's suppose you can short WE. And so let's focus on the expected returns. If we can short WE, that means that the weight of WE can actually go past this point. Do you agree with that? So if this is the graph for the expected returns, this is the expected return of E, expected return of D. The fact that you can short, so this is shorting E. The fact that you can short E, that means you will extend the graph that direction. Okay, so that means you are borrowing money at the rate equal to the expected return of equity, and you're investing that into debt. So if the weight of equity is negative, this means that the implication is that the weight of debt is greater than 1, weight of equity less than 0 in this section right here. Yeah. What if you can short D? Well, if you can short D, that means that the weight of debt is negative, which implies that the weight of equity must be greater than 1. So if your weight of equity is greater than 1, you're extending the graph to the right. Okay, so shorting, just like we did for the T-bills and the risky asset, you can short here too, and you, just like in the other setting, you're extending this graph one direction or the other, depending which one you short. Okay? So the key to figure out the graph is this part right here. When you short one asset, the weight is negative, that makes the weight of the other asset bigger than 1. Yep? Questions? What about risk? What do you think is gonna happen to risk? Debt. Equity. Let's suppose I short equity. What does it mean? If I short equity, that means that the weight of equity is less than 0. So using the same formula, the weight of equity less than 0 is on this side. That means that this graph will be extended on the left hand. So you're graphing more of that parabola than before. Before you were restricted between 0 and 1, now you're restricted below 0. What if you're allowed to short that? If you short D, that means that WD is less than 0, which implies WE is greater than 1. So you're now on this range, on this side of the graph. So this gets extended the other way. Okay, so shorting just extends the graph. Just be careful what is being shorted. Questions? You good? So what is the last case that is left? We dealt with the risky asset and the risk-free. 2 risky assets. The last case is, what if you're dealing with two risky assets and the risk-free asset. So now we're dealing with 3 assets in total. Yep. So let's think about this, how it could work. Suppose that of the possible expected returns, how do we call the portfolio that contained a risky asset and the risk-free? We give it a specific name. The one that contains the risky asset and the risk-free asset. The 2 risky assets combined, they make portfolio P, right? And P plus the risk-free asset produces what portfolio? How do we call it?
C.
C. Stands for what? Combined portfolio, complete. Yeah. Combined portfolio. So let's see what was going on here. We have, so complete. Suppose I invest only in debt, then I will have this combination of risks and returns, right? So my portfolio has a weight of debt equal to 1 and the weight of risk free asset 0, the weight of equity 0. This is what I invest only in equity and nothing else. But from here, we learned that when you mix equity and debt, you can generate a bunch of portfolios P depending on the weights that you pick, and depends on the correlation between E and D. Let's suppose you have some average level of correlation, whatever. So you get that. So what is the correlation here between A and D? Is there 1? How can you get this graph? The correlation, if correlation is 1, how does this graph look like in expected return risk space? If correlation was 1,
Maybe just a straight line.
it would be just a straight line. If correlation is -1, what would you get? The correlation -1 allows you to find a blend that makes the risk equal to 0. So for that particular blend or mix, you would have 0 risk. So you get the V shape thing. So this must be some type of negative correlation. We don't know exactly what number. What is the risk-free asset in this graph? Risk-free means what? 0 standard deviation, some level of returns. So the risk-free asset is there. Yeah, so those are the 3 assets we're working with. So if I want to find the ideal mix of those 3 things, one way to handle it could be, well, I can pick some weight WE and therefore some level of WD. If I combine only those 2 guys, I get some portfolio P. Do you agree with that? And so based on the weights I pick, using those formulas right here, I can calculate the corresponding levels of risks and returns. So let's suppose I create this portfolio P by choosing 2 values here. Go back to what we did earlier. Once we have generated this portfolio P, I can now mix P and RF by selecting some values for Y. Y was the weight of P. So if I just mix this risk-free asset and P for a bunch of different levels of combinations, I'll get these. So those are all the possible ways to mix this portfolio P with the T-bills. But I don't have to stop there. I can just say, well, what if I pick different set of weights? That gives me a different portfolio P. Let's call it P1. Then I can take this portfolio P1 and mix it with the risk-free asset. And by choosing all the different combinations of Y's, I can create all this combination of risks and returns. So this would be, help me out, the square and the star. What's the difference between the square and the star? Square. What are the 2 assets to get the square? I'm investing in to get this guy.
P prime and the risk-free
I'm investing in P prime and risk free. You agree with that? What about the star? It's also on the blue line, right? So how do I get this star portfolio? By investing in, what does the line connect? RF and P prime and RF. But what is the difference between the 2?
different weights.
Different weights, right? So here is invested mostly in Y, mostly in P prime, and this is mostly in the risk-free asset. Yeah? So by changing the mix WE/WD, I'm selecting points along this curve. And then by selecting the particular portfolio that I just created with RF, I generate points along this dashed line. Do you agree with that? So far, which portfolio is better, P or P prime?
P prime.
You sure?
Seems to be higher expected returns with lower risk.
So be more precise. For a given level of risk, say I need the Mirsto. For a given level of risk, whatever, just pick one at random. For the same level of risk, P prime produces higher returns than P. Yeah, so P prime is better than P. Got it? So, what is the minimum variance portfolio between A and D? Minimum variance means the one with the lowest risk. The one with the lowest risk will be the bottom of this curve right here. Let's call it MVP. What is better, MVP and T-bills, or MVP or P prime and T-bills?
MVP.
So can you tell me a general story here? If you want to know if a portfolio is better, if you could calculate the slope of this thing, of this line, the one that is better is characterized by
Crossing through the MVP.
a higher slope, right? The higher the slope of this segment, the more returns you're gonna get for a given unit of risk. Do you agree with that? So is there one that is best of all? Well, if you find the line with the highest slope, there is a portfolio in correspondence with that is the best risky portfolio that you can have. The best risky portfolio is the one that, when combined with T-bills, gives you the highest reward for any unit of risk. Got it? So even though you can create an infinite number of combinations between D and E, there is only a specific combination that makes the investor better off. And this combination is the one such that gives you the highest slope in the graph. And remember, if you think about slope is the change in y divided by the change in x. What's in the y-axis here?
Expected return.
Expected return. So it's the one that gives you the highest expected returns. And what's in the x-axis?
Risk.
Risk. So it's the one that gives you the highest expected return for 1 unit of risk you're exposed to. Okay. So when you throw in this risky asset to just when you throw in the T-bills to the 2 risky assets, the combination of portfolios that you can get increases exponentially. And nonetheless, there is one mix that is by far the best of all. Got it? So let's do this drawing all over again. You need to memorize this thing. This is the risk, the combined portfolio, the expected return, the combined portfolio that equity, T-bills. Yep. So which is the ideal portfolio here? Well, if I pick a random portfolio right here, or another one, let's call X, y. Eventually there might be 1. Where this line is tangent to the curve. This is the optimal mix of E and D. Okay? Questions? No? So as an investor, could I get this portfolio right here? Z.
Yes.
So I can get Z. It's possible to construct it. How would I do it? Well, let's suppose that, let's call this Z prime. I can find a way to mix E and D to generate Z prime, and then find the proper mix between Z prime and RF. So Z is possible. But is Z a portfolio I would like to have? No, because I can do better. I can get higher returns for that level of risk. And what is a better choice? Or if I just, even if I just use Y and mix Y with T-bills, I can find a blend between Y and T-bills that gives me a portfolio that has superior returns to Z. Yeah, so Y is better than Z prime. What about if this was the level of risk I wanted to be exposed to? Then this is by far the best I can get. How would I get this portfolio? Let's call it C. How could I get this portfolio C?
You
Well,
find C prime.
Figure out what is this optimal risky portfolio, figure that out, and then mix this ORP with T-bills. So think about how weird this thing is, because I'm gonna have to make this drawing again for the third time. And I'm gonna kind of do it stretched so that it's more visible. So this is my ORP, that equity, T-bills. So pick an investor who's very risk tolerant, and this investor will find this portfolio to be ideal. Then take an investor who's very risk averse, and the investor who's very risk averse will find this portfolio to be ideal. What's in common between the two portfolios? This is the, let's call this the risk tolerant, and let's call this the risk averse. What's the difference between RT and RA? How do you construct this portfolio? What do you need?
More of the risky assets.
So this one is composed of ORP and risk-free. What about this guy right here?
It's also composed of ORP and risk-free.
It's composed by or of ORP and risk-free. What's the difference between the two? Is by how much you mix ORP and RF. So here the weight, the Y, the weight for the risky asset here is greater than the Y right here. So this investor will invest in ORP. This investor will also invest in ORP. The only difference between the two to fix their preferences is that one is going to have a bias towards T-bills, the other one is going to have a bias towards ORP. So this is very important, because this is especially, basically this thing is saying all investors regardless of preferences, will invest in the exact same two assets. ORP and T-bill. So the best portfolio for everybody is this ORP guy and T-bills. Personal preferences will tell you the specific blend between the two. So like the super conservative grandpa should be invested in T-bills mostly and a little bit of ORP. The guy who's just trying to start out has an investment horizon of 50 years, is more risk tolerant, should be invested mostly in ORP and maybe a tiny bit of T-bills. But this is the striking conclusion of this thing, is that if you're dealing with those two assets, and you're dealing with investors with an infinite set of different preferences, all of them will end up, they will be best off with the exact same two assets to invest in. The only thing that changes is how they mix the two. Does it make sense? So what is the practical implication of these? Well, first of all, tell me what ORP is and how to get it, right? So we're gonna see that it was quite complicated to figure out, but if you have somebody that can do that kind of calculation, figuring out ORP is complicated, but then figuring out the blend between ORP and RF is a joke. It's the first thing that we did in this topic when we found Y star. So it's pretty simple. So this divides the task of creating an ideal portfolio into two components. One that is highly technical, which is computing ORP, and the other one that is pretty trivial. So you can have a guy that is paid a lot of money to figure out ORP, but once that person has figured out the weights, you can have people that are paid a little bit less skilled. All they need to do is figure out Y star and serve all sorts of different clients. Yep, does it make sense? Questions? So let's figure out the weights. That produce the optimal risk portfolio given equity, debt, and the risk rate. So we said, what is the logic to figure that out? We said, if you can compute a portfolio composed of E and D, so if you can create one of them, calculate its return and risk, so return and risk of X, Y, and so forth, and then calculate the slope of the line that connects this portfolio to the risk-free rate. So the idea is select weight of equity, weight of debt, and compute the expected return of P and the risk of this random portfolio P. Then use those values and compute the trade-off between expected returns and risk. So the way you would do it, the trade-off essentially, this is the slope of those lines right here. So this trade-off is going to be like this, is the expected return of P minus the risk-free rate divided by the sigma P. So this is the slope of this line, right? You have this line right here. You have the expected return of this portfolio minus the risk-free rate, change in y, divided by this distance right here, change in x. This ratio is important. This is called the Sharpe ratio. Sharpe ratio. So once you have calculated the slope of this thing, possibly repeat the process all over again by selecting different weights, calculating different expected returns and risk of this portfolio, calculate the new Sharpe ratio for the new portfolio, and keep doing like that, keep going like that. Eventually you will have, for any pair of weights of D and E, you will have a different portfolio that will give you a different ratio, and there is gonna be one pair that gives you the highest slope. Does it make sense? So try them all. Try this one, compute this ratio. Then create this portfolio right here. Compute this ratio right here. This guy divided by that guy. Eventually, once you get to this ORP, you have the highest gain in height for this same change in x. And that will give you the highest thing. Okay? So the pair weight of equity, weight of debt associated with the highest Sharpe ratio is the one used to construct this ORP. Okay, so test all of them, and eventually the one that gives you the highest ratio, this pair of weights, is the one that is associated with this ORP. So we can do this in a more mathematical way. And I'm gonna give you a formula that is gonna take a while to write down. So let's see how to do it analytically. To solve this problem analytically, finding the weight of equity, the highest Sharpe ratio. Do this. So you need to find WE such that the Sharpe ratio is maximized. So S stands for the formula right there, okay? So remember, the Sharpe ratio is equal to ERP minus IF divided by sigma P, where ERP is 1 minus the weight of equity, EFD, plus the weight of equity, ERE. So if you write things this way, you can see that the numerator depends on weight of equity. Only, that's the only variable. The rest are given from the problem, so those are fixed values. And sigma P is the weight of equity, sigma E squared plus 1 minus the weight of equity squared sigma D squared. That's weight of equity 1 minus the weight of equity sigma D sigma E. So the numerator depends on the weight of equity, the denominator depends on the weight of equity. So always the S is a function of the weight of equity divided by some other function of the weight of equity, which implies that S is some type of function of weight of equity. How do you find the highest value of a function? Take the derivative, set it equal to 0. So far we've established that this Sharpe ratio depends on the weights. You want to find the highest Sharpe ratio. So you take the derivative with respect to the weights, set it equal to 0, and solve. So find the weight of equity such that Sharpe ratio is maximized, which implies take the derivative of S with respect to W equity. Then set equal to 0, and so for W takes about 1 hour, and you will find W equals something. Okay, so this is the weight of equity that gives you the best combination of E and D when you can also invest in T-bills. So how does this formula look like? I'm gonna write it here because it's pretty big, and the way is I have it solved in my notes was for W instead. So make sure you write it. This is not WE, it's actually WD. If you find WD, can you find WE? How do you do it?
1 minus.
One minus whatever you got, right? So the transition is pretty simple. So wait until I write it, and then I'll tell you to copy it. So this is the way it looks like. Notice that I'm writing returns with a capital letter, so I need to define what that means. Normally I write it with lowercase. Yeah. Hold on, let me double check. The is closed right here. Okay, and where the capital R is the expected return of D minus the risk-free rate, and capital RE is the expected return of E minus the risk-free rate. We call those excess returns. Expected excess returns. Questions?
Beside the set, what's that supposed to be?
Say again?
So, S with the 2WE set, what's that supposed to say?
Okay, right here.
Yes.
So it says take the derivative. Once you have found taken the derivative, you take the derivative and you make it equal to 0.
Okay.
So set equal to 0, then solve for WE.
Gotcha.
And after you do all of the stuff, you're gonna end up with something that looks like this. Okay. So, main point, what is this WP giving you? What is this? This tells you WD such that you get the best portfolios. That can be constructed by mixing E, D, and the risk-free asset. Yep. So if you think about it, in order to solve this thing, you need to have information about E, D, and to calculate the excess returns, you need to have the TBA rate. Okay, so you have, this combines all three things.
We're out of time. We're out of time.
Out of time. That's it. You're out of time. So next time we're going to apply this thing, we're going to do a couple of examples, and then eventually we'll construct the best possible portfolio for some investors. And start working on the quizzes. This is pretty much the last topic we will take. And we have about
There you go.